Good morning. We cover division of polynomials today. The focus of today, division with the polynomials. We're going to see how do we use a polynomial to divide by another polynomial. If we have a polynomial p of x, and we need to divide p of x by q of x, both p of x and q of x are polynomials. We say p of x dividend. We call q of x divisor. Dividend and divisor. Yeah, so firstly, I want you to please remember the name of the two polynomials in the division. The order of the two polynomials cannot be interchanged randomly. The polynomial in front of division symbol, that's dividend. It's called a dividend. The dividend divided by the q of x is a divisor. Okay? All right. So the first example, we're going to see how do we divide a polynomial by a monomial. We are going to see how to divide a polynomial by a monomial. In other words, the first example, we're going to see the division with the polynomials as the divisor is a monomial. Let's look at the example. Let's see, divide 10x to the power of 6 minus 45x to the power of 5th plus 25x by 5x. All right, let's see. How do we solve this problem? If we say divide 3 by 2, we can write divide 3 by 2 as 3 over 2, right? The fraction bar here, numerator on the top, denominator on the bottom, is equivalent to a division symbol. So now we're trying to divide the trinomial here, 10x to the power of 6 minus 45x to the power of 5th plus 25x by 5x. So we can write the trinomial in the numerator as numerator. And then the division symbol, we draw it as a fraction bar. By 5x, 5x is a monomial. Okay. Anyone can tell me which polynomial is dividend, which polynomial is divisor? Which polynomial is dividend, which polynomial is divisor? Yeah, the divisor is 5x. The denominator, the polynomial in the bottom, that's the divisor. That's the divisor. The polynomial in the top, that's the dividend. Very good. So this problem, we're going to see how do we divide a polynomial by a monomial. Yeah. How do we process a division of polynomials when the divisor is a monomial? Firstly, I'm going to give you a formula. We have 3 fractions with common denominators 8. The 3 fractions are 1 over 8, 2 over 8, 3 over 8. Yeah, this one is 3. Yeah, anyone can tell me how do we add them up? How do we add fractions with the same base, with the same denominator? We learn this rule. Keep the bottom, solve the top, right? Keep the bottom, solve the top. Am I right? Okay, very good. So now I'm going to switch. That's an equation. I'm going to switch the left-hand side and the right-hand side of the equation. I'm going to write that equation as 1 plus 2 plus 3 all over 8. Yeah, that's right-hand side, right? I'm going to write on the left equals. The right-hand side is going to be on the right in the new equation. 1 over a plus 2 over a plus 3 over a, right? I believe you agree this is true, right? Is this equation also true statement? Yeah, they are the same equation, right? Same equation, of course, it's correct. It's a true statement. And this true statement tell you how do we divide a polynomial by a monomial. Let me show you. If the numerator has more than one terms, in this case, 3 terms, right? Part 1, part 2, part 3, or term 1, term 2, term 3. And the denominator is one term only, then we can write the division as the term 1 in the numerator divided by the denominator plus term 2 in the numerator divided by the denominator plus term 3 in the numerator divided by the denominator. That's how we process this division in example 1. Am I clear? Yeah, let me say it again. Numerator has more than one terms, right? Yeah, part 1, part 2, part 3. Denominator is just one term. Then we can use every single term in the numerator to divide by the denominator and add them up. So term 1 in the top divided by the denominator plus term 2 in the top divided by the denominator plus term 3 in the numerator divided by the denominator. We are going to use this rule to process our division here. Okay, how many terms in the numerator? 3 terms in the numerator. How about let me color them. Term 1 in the numerator is blue. Term 2 in the numerator is green. Let's use the purple for the term 3 in the numerator. And the denominator, how about let me use orange? Okay, so by the rule that I have just shown you, we can write this division as term 1 in the numerator divided by the denominator. So blue over orange. Do you agree? Plus green, which is a negative. Be careful, the sign is a part of the term. Negative 45 x to the power 5th over orange. Plus the term 3 in the numerator is the purple. 25x over the denominator 5x. So you see, blue plus green plus purple all over orange is equal to blue over orange plus green over orange plus purple over orange. Yeah, that's how do we process a division when the divisor is a monomial. Okay, we're not done yet, of course. Let's look at the first part. Let's see how do we simplify this expression. Numerator is 10, denominator is 5. Numerator is 10, denominator is 5. 10 over 5, what do we have? 2, yeah, so we have 2 here. And numerator has x to the power 6. Denominator has x. Yeah, I would remind you to look at the quotient rule we learned a few days ago. Yeah, quotient rule. Quotient rule. X to the power 6 in the numerator, x in the denominator. So the denominator exponent of x is 1, right? Yeah, 5, exactly. We keep the base. Use the exponent in the numerator to minus the exponent in the denominator, right? We have x to the power 5th. Everybody see that? Okay, very good. Let's continue. Let's see this part. Negative 45 over positive 5. So the second term is going to be negative or positive? Negative. Awesome. Thank you. What's 45 over 5? 45 over 5. 9. Yeah, very good. And you have x to the power of 5th in the numerator. You have x to the power of 1 in the denominator. Yeah, exactly. Quotient rule again, right? Same with earlier. Okay, that's the second term. Let's see the term 3. 25 in the numerator, 5 in the denominator. 25 over 5. 5, okay. X in the numerator, x in the denominator. Do they just cancel? Yeah, so we don't have x, right? Yeah, that's okay. And that's the answer. You see? That's how do we divide a polynomial by a monomial. Write them as a fraction. Use a fraction bar to replace the division symbol. Put a dividend in the numerator. Put a divisor in the denominator. Divisor in this case is a monomial. And you're going to use every single term in the numerator to divide by the monomial in the denominator. And then you simplify. Okay, I'll give you one problem to practice. You are going to try this one. Give me 1 second. Give you a couple minutes. And this is yours. The rule or formula is right above it. We have a division here. The fraction bar here is the division symbol. Numerator is a trinomial, right? It's the dividend of the division. Denominator is a monomial. It's the divisor of the division. I'll give you a couple of minutes. Any progress? One. Yeah. 6y fourth, 6y fourth. They are identical. 1. 1. Does they all cancel? Okay, let's see. Let's see how do we process this problem. Numerator, 3 terms, right? Term 1, 42y power of 10 over 6y to the power of 4, plus term 2 in the numerator, negative 18y to the power of 8th over 6y to the power of 4th. Term 3 in the numerator, 6y to the power of 4th over 6y to the power of 4th. Simplify. 42 divided by 6, 7. Y to the power of 10 over y to the power of 4. 10 minus 4, 6. So we have y to the power of 6. Second term, negative over positive, so it's a negative. 18 over 6, 3. Power of 8 in the numerator, power of 4 in the denominator. 8 minus 4 is 4, so y to the power of 4th. Term 3, yeah, you see the numerator and the denominator are identical. Everything is cancelled, right? So you have a 1. You have a 1. Is that clear? All right. That's the first example. First example showed you how do you divide the polynomials when the monomial is very special. I'm sorry, when the divisor is very special, the divisor is a monomial. What if the divisor is not a monomial? Okay, so that's example 2. When the divisor is not a monomial, we have to apply long division to divide the polynomials. Okay, we have to apply long division to divide the polynomials. So I write a rule in the question. Yeah, please also copy it down your note. What if the divisor is not a monomial? How do we process division of polynomials? We're going to apply long division. Let me show you. Let me get this question. See which one. This is a good one. Let's get this one. For long division, please take notes. Write down all the details. Yeah, as the name shows, long division is very long. Unfortunately, it's a very long process, and a lot of details. So we are going to see how do we divide 4x cubed plus x plus 5 by x plus 2. Anyone can tell me what's the dividend? What's dividend in this case? What's divisor? What's dividend? Is x plus 2 dividend? No, yeah, you're right. So the one in front of the division symbol, right? That's dividend. Very good. Dividend. And x plus 2 here is a divisor. You can see divisor x plus 2 is a binomial, right? So the method we got earlier in example 1 doesn't work here anymore. Yeah, we have to apply long division. Please write down a sentence. To get ready. To get ready for long division. Write both. Yeah, I have an accent. Write both dividend. Yeah, I dream about like I can remove my accent one day. It's really hard. Write both dividend and divisor in the standard form. Yeah, let me write this standard form in red. Standard form means it's important. A common mistake, for people when they apply long division, a common mistake is they miss this step. They didn't write both dividend and divisor in the standard form, and then end up with a wrong answer. So super important. Okay, super important. You have to get ready for long division. How do you get ready for long division? You need to write both dividend and divisor in the standard form. Do you guys still remember standard form? A while ago when we learned definition of a polynomial. Do you guys remember that? Let's see the dividend. The dividend here is dividend. Dividend here is 4x cubed plus x plus 5, right? Can you tell me the degree of the dividend? What's the degree of the dividend? 3, okay. What's 3 plus 1? 4. Remember this, we covered this a few days ago. When the degree is 3, you add a 1, you have 4. The standard form of this polynomial is supposed to have 4 terms. How many terms do we have right now? Means one term is missing, right? Yeah. Okay, let's see which term is missing. Degree is 3. Leading term is 4x cubed. Do we have x squared term? Do we have x squared? No. So what should we do? Remember that? 0, right? Coefficient is 0, Lauren? Yeah, 0 times x squared. Yeah, we are missing x squared term. We have to write it out with coefficient 0. Do we have degree 1 term? Do we have degree 0 term? Constant, again, once a single constant is a monomial with degree 0. Now the equation, not equation, the dividend is in the standard form, right? Okay, suppose again. So now the dividend, the blue, is in the standard form. Let's see divisor. Divisor here is x plus 2. What's the degree of x plus 2? Degree of x plus 2. 1, yeah. 1 plus 1 is 2. Is x plus 2 already in the standard form? Yeah, that is already in the standard form. Okay. Super important. Let me, I cannot emphasize more. Remember to write both dividend and divisor in the standard form before you actually start the long division process. Okay, now we have both dividend and divisor in the standard form. We can finally start the long division process. How do we start it? This notation is the long division notation. Okay, like a roof. It's a long division notation. Yeah, you're gonna put a dividend, the blue, put a dividend under the roof, the blue one, and no, make sure the dividend is in the standard form. So you're gonna put 4x cubed plus 0x squared plus x plus 5. You put a dividend under the roof. Put a dividend under the roof. Make sure it is in the standard form. Degree 3, 4 terms. And where do you put the divisor? You put the divisor to the left of the division symbol. Okay, next to the division symbol. You are dividing the blue by the green. Okay, are you guys ready? Please copy down the steps in the long division. It is divide, multiply, subtract, compare, bring down. Okay, you need to write those sentences down, okay? Divide word by word. Divide leading term. You see, why do we need to learn leading term earlier, right? Divide the leading term in the dividend, yeah, a lot of word, by divide leading term in the dividend by the leading term in the divisor. Okay, yeah, multiply word by word. Yeah, let's copy them down first, and then we're gonna make sense of them. Let's copy them down first. Multiply word by word. Multiply the quotient you get from previous step by the divisor. Okay. Subtract. I don't want to. Subtract is hard to describe. Write a process. Subtract. I'll show you about that. Let's say compare the degree of the remainder with degree of the divisor. Bring down if. Bring down if the degree of the remainder is not strictly less than the degree of the divisor. Yeah, basically, we have all the details for divide, multiply, compare, and bring down. For the subtract, I'll show you that step, and maybe you can write a description in your own word. Okay? Yeah, let me know when you finish. Divide leading term in the dividend by the leading term in the divisor. Multiply the quotient you just get from previous step by the divisor. Compare the degree of the remainder with the degree of the divisor. Bring down if the degree of the remainder is not strictly less than the degree of the divisor. Yeah, not completely, not 100% all the details, but most of the details. Most of the details is right here. Let me know when you finish. As I said, the long division is very long. Yeah, be patient. Ready? Not yet? Okay. Ready? Yeah. Okay, all right. Okay, let's see. Divide. The first step, divide. Divide what by what? Leading term in the dividend. Tell me what's the leading term in the dividend? What is the leading term in the dividend? Leading term in the dividend. Yeah, what's the dividend? This is the dividend, right? What's the leading term? Yeah, very good. Divide the leading term in the dividend by what? By the leading term in the divisor. What's the leading term in the divisor? Yeah, okay, awesome, very good. And what do we have? What's the quotient? 4x cubed over x. What is it? Yeah, 4x squared, very good. X cubed over x, right? Yeah, 3 minus 1 squared. Okay, you got a 4x squared. You're gonna put 4x squared. This is a quotient, right? Yeah, we're gonna write this quotient right above the roof, the symbol, division symbol. And the reason we write 4x squared right above 0x squared is because they are like terms. I do not write 4x squared on top of 4x cubed because they are not like terms. I do not write this here above x because they are not like terms. Okay, do you see what I'm talking about? Yeah, I write above, I write 4x squared right above 0x squared because they are like terms. Long division is very, how do I say that? In order to do long division, you have to keep everything very organized. Yeah, make sure vertically all the terms are like terms. That's the first step. What's the second step? Multiply what by what? Multiply the quotient you just got, which is the 4x squared, right? By what? What's the divisor? X plus 2, right? So you are multiplying 4x squared by the binomial x plus 2. Yesterday we have covered how do we multiply a monomial by binomial. Distribute, right? Can you distribute and let me know what's the product? 4x squared multiplied by parentheses x plus 2. We apply distributive property. 4x squared times x plus 4x squared times 2, right? Distribute. Yeah, okay. What's 4x squared plus x times x? 4x squared times x. Very good, x cubed. Yeah. And what's 4x squared times 2? Very good, 8x squared. So that's the product, okay? Subtract. Yeah, we didn't write the detail. Let me tell you how do we process that step. We got a product here, right? 4x cubed plus 8x squared. We are going to put that product right under the dividend. Again, make sure all the terms vertically are aligned. 4x cubed plus 8x squared. Okay? Yeah, we're gonna put the product right under the dividend. And then we're gonna subtract. Let me explain subtract what from what. We are going to subtract the product from the two terms, from the terms right above it. Okay? But instead of subtracting, this is what we're gonna do, okay? Yeah. How about let me color. These two terms are purple, right? The product we got is in orange. We are going to use purple minus orange, or we subtract orange from purple. But instead of subtracting, we are going to change the sign and then do the addition. The orange, the two terms in orange, both of them are positive, right? Yeah, we are going to change the sign and we write them as a negative. And then we add them up. Yeah, so for step 3, subtract. Instead of subtracting vertically, we change the sign in the product, and then we do the addition. Am I clear? Everybody, am I clear? So how's it go? So we are subtracting. So the product we got from step 2, right, is this. We put that right below the dividend and make sure vertically all the terms are like terms. So we are going to subtract the orange from the purple. But instead of subtracting, we change the sign in the orange. They were both positive. We change them to negative, right? And then we do the addition. Yeah, instead of subtracting, we change the sign and do the addition. Okay? Yeah. Okay, perfect. So let's do the addition. Let's see what we have. Vertically, 4x cubed, negative 4x cubed. Do they cancel? Yes, okay. 0x squared minus 8x squared. Yeah, negative 8x squared. Okay. What is this guy? This is the first remainder. Yeah, it's not a remainder of the division. This is the remainder in the middle. Yeah, at this point, we got a remainder, right? Okay, compare. Next step, compare. Compare what? Compare the degree of the remainder with the degree of the divisor. Tell me what's the degree of the divisor? 1. Okay, what's the degree of the remainder? 2. Yeah. We stop the whole process when we see the degree of the remainder is strictly less than the degree of the divisor. But now it's bigger than, right? We continue. We're gonna bring it down. Yeah, bring down. We bring down if the degree of the divisor is not strictly less than the degree of the divisor, right? Bring down what? Bring down the next term 3 in the original dividend. This guy, x here. Bring it down. Okay? Is that clear? Yeah. Bring the x down. So we have a blue binomial here. I wrote it in blue. Negative 8x squared plus x. And that is going to be the new dividend. Okay? This is going to be the new dividend. And we are going to apply the steps another times Sometimes we might need like a few rounds. Yeah, in this case, obviously the one round is not enough, right? Let's see how many rounds do we need to apply. So for the new dividend, again, now we have negative 8x squared plus x. That is the new dividend. We're going to start the second round. Step 1, divide. Divide what by what? Divide the leading term in the dividend by the leading term in the divisor, right? Yeah, again, the dividend right now is this guy. That's the new dividend. Yeah. What's the leading term of the dividend? Yeah, negative 8x squared, right? Yeah. Yeah, because that's a new dividend. Am I clear now? Okay, very good. So divide the leading term of the new dividend. We're going to start the second round, which is negative 8x squared by the leading term in the divisor. Divisor always divisor there. It doesn't change. What's the leading term in the divisor? What's the quotient? Huh? Quotient. Negative 8 over 1, x squared over x. Negative 8x, right? So where do you put that quotient? You are going to put a quotient above the division symbol, above the roof, right? Yeah, and on top of x, because they are like terms. So we are going to put a negative ax right here. Okay? So that's good. Second step, multiply. Multiply what by what? Everybody, multiply what by what? Negative, multiply the quotient you just got, which is negative ax, right? By the divisor, which is x plus 2. Can you tell me what's the product? Very good, perfect, yeah. So we are going to put down right below the dividend. Again, the dividend is the second round, the dividend is the second round. Negative 8x squared minus 16x. Okay, so again, we are using the purple minus the orange. Again, we are subtracting the orange from the purple. But instead of subtract, we do the same thing. We change the sign and we do the addition. Look at the orange. Are both two terms negative? They are both negative, right? Yeah, yeah. So we're gonna change them to positive. Change them both to positive. Change every single term in the orange to the opposite sign. And then we do the addition. Look at the purple and the orange. Negative ax squared, positive ax squared. Do they cancel? They add up to 0, right? Okay. What's x plus 16x? X plus 16x. 17x, okay. 17x. Let me use the green. 17x. And that's the new remainder. That's the new remainder. Yeah, that's the remainder in the second round. Compare what by what? Compare the degree of the remainder. What's the degree of the green remainder? So yeah, 1. What's the degree of the divisor? 1. It's not strictly less than, right? So it means we have to continue. So bring down. Bring down what? So you're gonna use this 5 here. Okay? You're gonna bring down 5. Bring 5 down. And 17x plus 5 in green. 17x plus 5 in green is gonna be the new dividend. We are starting the third round, another round. Okay? Number 3, another round. Another round. Okay. Again, the binomial on the bottom, 17x plus 5, that's the new dividend. Let's see the first step. Are you guys able to hear me well? What if I do not have a speaker? Are you able to hear me well? Okay. Okay, so the new dividend is 17x plus 5, right? 17x plus 5. Let's start the third round. What's the first step? Divide the leading term in the dividend by the leading term in the divisor. What's the leading term in the dividend? The dividend is the green one, 17x, right? Yeah. By the divisor, by the leading term in the divisor, what's the leading term? X. What is the quotient? 17. Okay, we're gonna put a 17 above the notation and then right above 5. Second step, multiply. Multiply what by what? By x plus 2. Okay. What is 17 times x plus 2? Very good. So we're gonna put a 17x plus 34 right below the dividend, right? And move to the next step, subtract. We are going to use the purple to minus the orange. We're gonna do the same thing with before, right? We change the sign in the orange and we do the addition. Look at the orange, 17x plus 34. Both terms are positive, right? We are changing them to negative, And then we're gonna add them up. 17x minus 17x, what do we have? 0, right? And what's 5 minus 34? Negative 29, right? Okay, compare. Negative 29. Let me write in different color. Negative 29, the black, is the new remainder, right? Tell me what's the degree of the new remainder, negative 29? 0 is a constant, very good. What's the degree of the divisor? 1. Finally, the remainder, degree of the remainder is strictly less than the degree of the divisor, right? Yes? Okay, we can stop here. Yeah. So when we see the degree of the remainder is strictly less than the divisor, degree of the divisor, the process of long division is done. Okay, let's interpret the result. How do we understand the result? We know the dividend. Okay, I'm not having this, right? The dividend is below the division symbol, 4x cubed and so on, right? This is dividend. And this is divisor, right? We are dividing this polynomial by that. The quotient, we are looking for the quotient, right? The quotient, where do we find the quotient? This is the quotient. Okay? The quotient, you find the quotient above the division symbol. The quotient is 4x squared minus 8x plus 17 with remainder negative 29. Yeah, so here is the remainder. Remainder of the whole division, the whole process. Okay? For example, if we divide 50 by 3, okay, let's see. How do we divide 50 by 3? We have 1 here because 3 goes into 5 one time, right? Yeah, 1 times 3 is 3. The remainder is 2, right? And we bring down 0. How many times 3 goes into 20? 6, right? Yeah. 3 times 6 is 18. Remainder 2, right? So you can see when we divide 50, which is a divisor, which is dividend, when we divide 50 by 3, we got a quotient 16, remainder 2. Does that make sense? Does that make sense? When we divide 50 by 3, we got a quotient 16 with remainder 2. Means 3 does not go into 50 completely 16 times. Yeah, after 3 goes into 50 16 times, we still have a remainder 2, right? That's how do we understand when the dividend and divisor are numbers.
Same with here. Same with polynomials, but of course it's more complicated. So when you use the dividend divided by divisor polynomial, you got a quotient, which is a quotient polynomial, with a remainder -29. Yeah, this polynomial, the divisor x plus 2, does not go into the dividend completely. It has a remainder. Does that make sense? This is the whole process of long division. Let's make a summary. It's very long. I didn't time us. Did we spend a little 20 minutes here? Probably 20 minutes, right? At least. Okay. Very, very important. Before you apply the long division, before you start the process of long division, what do you need to do? Yes, standard form. Very, very important. Yeah, that's a common mistake. Common mistake is they didn't write the two polynomials in a standard form and end up with the wrong answer. Once we get ready, we put a dividend under the symbol, divisor to the left of the symbol, and we apply the 5 steps: divide, multiply, subtract, compare, bring down. We apply the 3 rounds here, right? Until the remainder has a degree strictly less than the degree of the divisor. Then we are done. And I just show you how do we interpret the result. Where do you find the quotient? Where do you find the remainder? Yeah, in the case the remainder is 0, in the case the remainder is 0, the divisor goes into the dividend completely. In the quotient is whatever on top of the symbol. Okay, your turn. Your turn. Let me which one I'm gonna ask you to practice. How I'll give you a simple one. Try this one. Take your time. Long division. How do you get ready for the long division? Are they already? Yeah, this one, we don't have to do nothing because they are already. That actually is the reason people make a mistake. Because maybe many times they do not have to write a polynomial in the standard form because they are already in the standard form. So over time they forgot they have to have them in a standard form. Sounds like something serious happened. Let me write the steps for you. You have the detail on your note. Very good. Yeah, yeah, that's true. Go to the long division. Oh. They are not like terms. How about the 1x? Yeah, you put 9x right above the 1x. Remember, long division vertically, all the columns, those terms have black ones. And you multiply. Very good. Every time. Compare, right? Do you have the multiply? You multiply the quotient you got by the divisor, right? What do you have? You multiply 9x by x minus 6, and you write it down. If you try to do it, you will have 9x times parentheses x minus 6 parentheses x minus 6. 9x or times, that's what. Okay. So when you multiply monomial by a 5, you have a 5 product. You dispute, right? 9x times x times 1, 9x times 26 is negative, right? 9 times negative, negative 4x. What is x? 9x times x. That's the product, right? What product below that? We're missing one. Subtract, right? Right? What is it? Right? You subtract. You change the sign, add them up, right? This is a positive, you change it. This is a negative, you change it to positive. So they add up to 0. Right, they are opposites. And what is the negative one? 3x positive x. It is practice, but you are on the right track. Because the degree is 1 with 1 square, 2 to bring it down. Yeah, 0 you do not right. Very close. See the time. How about let's look at it together. Divide what by what? Leading term in the dividend, but the leading term in the divisor, right? What's the quotient? Where do you put 9x? Please do not put it here. Why? They are not like terms, okay? Put it here, because they are like terms. Yeah, multiply the quotient by the divisor, which is x minus 6. Tell me, please, what's the product? 9x times x. 9x times -6. Yeah, okay. We put the product right below the dividend. And we're gonna subtract, right? Instead of subtract, we change the sign and do the addition. Positive becomes negative. Negative becomes positive. Vertically, add them up. Positive 9x squared, negative 9x squared, add up to 0. Negative 51x, positive 54x. So you have 3x here, right? Yeah, okay. What's the degree of 3x? 1, which is not strictly less than the degree of the divisor, which is 1 as well. So bring down. And start again. Divide. So the 3x minus 18 now is the new dividend, right? Okay, divide the leading term in the dividend 3x by the leading term in the divisor x. What's the quotient? 3, positive 3, okay? Yeah, positive 3 here. You write positive 3 right above -18. And multiply the quotient 3 by the divisor. What's the product? -18. Yeah, 3x minus 18. You do not have to, change the sign and addition. Obviously, they are identical, right? Whatever the thing minus itself, you have 0. So here is very obvious. The subtraction is 0, right? Is 0. Yeah. So in this case, the divisor goes into dividend completely. Okay. Yeah, the quotient is this polynomial 9x plus 3. Yeah, this is a easier case compared with our example. Example uses 3 rounds. We use here 2 rounds, right? And the remainder is 0. The division is complete. Any question about long division? Any question about long division? Okay, are you guys ready for prepare for test 4? Yeah, we're gonna start a review for test 4. Test 4 takes place on Monday, and Tuesday we will have the final. We do not have time to review for final, but I have the study guide of the review in Moodle. Let me show you where do you find it. You go to Moodle. And you see the test reviews, right? Your final review is here. Because we really don't have time to cover. All right. Yeah, you will have a 50 questions in the final. 50 questions, multiple choice questions. And now we are going to start a review for test 4. Review for test 4. Review for test 4. How many questions in test 4? Hold on, this is not very, it's not very clear, right? How about it is okay. Can you see the clear or not? Oh yeah, now it's fine. Okay, very good. Okay, how many questions in test 4 on Monday? I think it's 26 questions. 26 questions. Let's see the first one. First problem. Writing the expression using exponents. 1, 2, 3, 4, 5. 2, 3, 4, 5. How do you write this product as an exponent, as a power? This is a repeated multiplication, right? Yeah, very good. 3 to the power of 5. The base is the repeated factors, repeated factor in the product. How many times you repeat it? 5 times, so that's the exponent. The first problem is easy, right? Yeah. Take the note. The first problem is very straightforward. What if I give you this? What should you choose? What if the product is 5 times 5 times 5? 5 cubed, yeah, it's different, right? Very good. Number 2. The second problem is 1, 2, 3, 4. Negative 3x times negative 3x times negative 3x times negative 3x. We see this expression is also a repeated multiplication, right? How do you write the repeated multiplication as an exponent? You need to identify what's the base, what's the exponent, right? As a power. What's the base? Negative 3x. Be very careful. Yeah, the base is not a 3x, it's a negative 3x. So you need to have a parenthesis. You need to have a parenthesis to frame a negative 3x. What's the exponent? 1, 2, 3, 4. 4 times, right? Okay. So if you look at ABCD, it's a multiple choice question. If you see this, would that be the same? If the negative sign is outside the parentheses, would that be okay? No, it's not okay. Obviously, this is a positive because the power of 4. And this is a negative. It's not okay, okay? The negative sign is a part of the base. And what if you see the answer choice is negative 3x to the power of 4 without any parentheses? Would that be okay? Not okay, yeah. Without a parentheses, this means the base is x by itself. Negative 3 is a coefficient. The structure is different. Do you see what I'm talking about here? And the structure is very important. With the parentheses means the base is negative 3x. Am I clear about that? Yeah, please take a note. Yeah, please be careful with the parentheses. Yeah, multiple choice question has advantages, has disadvantages. Advantages is you can apply method of elimination, right? Disadvantage is sometimes I give you the answer choices like distracting you, confuse you, because they look so similar, but they are different. Structures are different. Any question about number 2? Do you have the note? Note? Okay, number 3. Number 3, you will be given a power for exponentiation. You need to identify the base and the exponent. So kind of like opposite with earlier, or the other way around. Number 1, number 2, you are given repeated multiplication. You need to write the repeated multiplication as exponentiation. Number 3, you are given an exponentiation. You need to identify the base and the exponent. What's the base? Negative 11x, not a positive, okay? Yeah, it is a negative 11 times x, the whole thing in the parentheses. That's the base. What's the exponent? 13, right? Yeah, is that doable? Is this problem doable? Number 4, let's see what's number 4 here. Same requirement, but this time, the expression is a negative 13 to the power of 5. You do not have a parenthesis. You need to identify what's the base and what's the exponent. Yeah, what's the base? You probably know what's the exponent, right? Exponent is definitely 5. What about the base? No. What's the base? 13. Okay, yeah. So number 4 might be a little bit confusing because you don't have a parenthesis. In number 3, you have a parenthesis. Obviously, the base is whatever inside the parenthesis, right? Yeah. The 13, the exponent is on the shoulder of the parenthesis. And here, the exponent is 5. Where the 5 is, whose shoulder? Number 5 is on. 13, not a negative 13. And this negative sign is not a part of the exponentiation. You see that here? Yeah. So this is the opposite of a power. The power has base 13, exponent 5. Okay? Yeah. You will see something similar. Yeah, do not choose the base negative 13. The base is a positive 13. Okay? Number 5. Let's see what's number 5. Simplify 7 to the power of 3 times 7 to the power of 5. Seven to the power of 3 times 7 to the power of 5. 8. Yeah, 7 to the power of 8. Yeah. What formula you apply? Product rule. Very good. Yeah. You apply product rule when you multiply 2 powers with same base, right? You are multiplying 2 powers with the same base 7. You keep the base, add the 2 exponents. 3 plus 5 is 8. And that's the answer you are going to choose. Yeah, you will see 7 to the power of 15, but please do not choose that. Yeah, the 2 exponents, 3 and 5, you are going to add them up. You are not multiplying them together, okay? Any question about number 5? Number 6. Simplify 3 to the power of 5 in a parenthesis and then to the power of 2. Is that clear, Lauren? 3 to the power of 5 in a parenthesis and then to the power of 2. How do you simplify this number? You multiply the 2 exponents. Keep the base 3, multiply 5 and 2, you have 3 to the power of 10, right? You might wonder, do I need to multiply 3, 10 times to get the result? You do not have to because it's a multiple choice question. Yeah, you will see 3 to the power of negative 10. Sorry, 3 to the power of positive 10 in the answer choice, and you just choose that. Okay, you do not have to give me the value. What is the 3 to the power of 10? The purpose is to see if you know power rule, okay? You apply power rule when the base of the power is the power itself. So you keep the base of the base, multiply the 2 exponents. Any questions? Number 7. See what's number 7. Number 7 is also very straightforward. You're going to choose from A, B, C, D. That is the same with the given expression. Let's look at the structure of the given expression. The exponent is 5. Exponent is 5. The base is a quotient, right? 9 over 8. So the structure of this expression is a what? Power of what? Quotient, yeah. So we're gonna use the power of quotient formula. The rule for that formula is the power of quotient equals the quotient of powers. So can you apply the formula? Tell me quotient of powers. What's the quotient of powers? 9 to the power of 5 over. Exactly, that's what you're gonna choose. Okay, yeah, that's the answer you are going to choose. Very straightforward. Very straightforward. Quotient, power of quotient. Let's see number 8. Number 8 is 3t to the power 7. Simplify this expression. Yeah, this expression obviously is exponentiation, right? What's the base? Parentheses. The base is parentheses, 3t, right? And what's the structure of the base? 3t. 3 times t. The base is a what? 3 times t. The base is a what? Addition, subtraction, division. Yeah, multiplication is a product, right? So do you see this expression is the power of a product? Power of a product, right? 7th power of the product of 3 times 7, 3 times t, I'm sorry, 3 times t. So what formula are you gonna apply? Power of a product, yeah. Power of a product equals product of powers. Yeah, tell me, how do you do that? How do you apply power of a product? 3 to the power 7, t to the power 7, right? Yeah, can you figure out what is 3 to the power 7? You should have a calculator. Yeah. If you do not see 3 to the power 7 in A, B, C, D in the answer choices, just figure out what is 3 to the power 7. Okay, is 3. What is 3 to the power 7? 27 times 81 is a very big number, right? Yeah. Any questions? Let's do one more. Number 9. Number 9 is negative 13 to the power 0. Evaluate expression negative 13 to the power 0. I want you to see the difference between the given expression and this expression. The expression has a parenthesis, right? Okay. Can you tell me what's the value of this expression? Use the is 1, yeah. If you see a power with exponent of 0, look at the base. As long as the base is non-zero, you don't have to worry about what's the value of the base. As long as the base is non-zero, okay, it's 1, period. But this expression and the expression we are given, they are different, right? Do you see the difference? Yeah, what's the base here? 13. The negative sign is not a part of the base, okay? So the structure of the expression, so this negative sign can be understood as opposite. So it's the opposite of 13 to the power 0. What is 13 to the power 0? 13 to the power 0. Ian, what's 13 to the power 0? 1. 13 to the power 0 is 1. Yeah, here. If the exponent is 0, it doesn't matter what's the base. As long as the base is non-zero, that is 1. Opposite of 1 is negative 1. So be very careful. People mess up number 9 because they don't see the structure very clearly. Thank you guys for coming. I'll see you tomorrow.